Right. Hello, everyone. Hopefully you can hear me. Um, and Happy New Year. Yeah, that was the other thing. Yeah. Um, Thanks for coming. The purpose of these sessions, which will happen every single week at the same time, hopefully, are to answer any questions you might have. There is a chat. If you want to send me anything, I will be able to respond. I don't think anybody else can see your questions, but we can test it shortly. Um, My intention is to do a little recap of some of the different things that we have been doing with the different year groups this week, including the topics that you can see on the screen. Um, if you have any specific questions around it, then tell me some of these things you won't have done in the last week or so because we've done a different topic with you. Some of them you will be able to, we will have done. And then some of them you might find a little bit difficult if you're in year nine because you might have not done that specific one with us. But what I'm going to do is I will first recap. If you have any questions, by the way, any of the homework or anything like that, then do send it. Oh, there's a Q&A. Didn't see that. Oh, composite and inverse functions using algebraic expressions. Yeah, all right. I'll try and do that. Yeah, fine. I'll get to that. But what I'll do is I'll do a little recap of the stuff that we have done um, this week, and then I will get to that stuff. I'll have to pull out some questions for composite and um, inverse functions shortly, which I'll do, but that's fine. So I'll get into it. But if you have any other questions again, then just say them or write them in the Q&A bit or in the chat. Either way, it should be fine. I think I've got a few things open here. Right, should be able to see everything. Okay, right. So firstly, what I'll do is I'll just do a little recap of some of the area and volume bits. This won't take very long, this bit of it, but as a little reminder of some of the things that you need to be able to work out areas of, they include things like rectangles. If I said to you work out the area of this shape and it was a rectangle, you would do 3 multiplied by 2 to get 6. For today, it's really up to you. Today, because we've most recently done maths, I am going to do the most recent maths topics. And then as we week by week, my intention is with these sessions is to recap the topic you've done that week. So, for example, in the next week with us, you will do um, some biology, and then I can do a recap of that. But I'm fairly flexible. So if you have any specific questions on anything, then I can answer them. But today, in terms of if there's no other questions, I will focus on the most recent maths stuff that we have done. And then, as I say, week by week, I'll just do whatever we've done most recently and answer any other questions. So it's fairly flexible, but unless I have specific questions, I will do what we have done most recently in the um, thing. Oh my God, I've got captions running here. I didn't see that. Okay. Fine. Right. So, as I say, I'll just go through some of these things, but if you have any specific questions, then just ask them. So, area, volume, that is how you work out the area of a rectangle. You multiply the length by the width. If it was a triangle, then please remember that you need to halve something. So if I give you something like this, then the area of this triangle is a half times 4 times 5. And also, in order to work out the area of a triangle, you must have the vertical height of the triangle. Sectors with Pythagorean trig has been asked as well. Um, okay. Half times 4 times 5 is obviously 10 because 4 times 5 is 20. I'll take my watch off. If you had the area of a trapezium, I'm just going to do that as well, then you would need some information such as you would need to know that that is 4, for example, that is 10, for example, and the vertical height, let's say, is 3. If you had to work out the area of this shape, there's a few different ways to do it. You could split this up into a couple of triangles and a rectangle in the middle, but there is a formula which you will get given, which is a half a plus b times h, where a plus b or a and b refer to the two parallel sides which are there and there. And the h obviously refers to that number. So if you did this for this question, it would be half of a plus b, which is 4 add 10, times the h, which is 3. 4 out of 10 is 14. Half of 14 is 7. 7 times 3 is 21. Units for area are centimeters squared. So if that was centimeters, then all of this would be in centimeters squared. If it had been meters, it had been meter squared. God, there's more questions. Um, Solving equations. Yeah, I'll deal with that. Probability, Venn diagram, hard question. I'll do my best to get to some of those. In terms of timings, I will try to. I've allocated a couple of hours every week to this, so up to 2 hours. We'll just see how it goes, and we'll do a little bit of everything until people are satisfied. Ratio, it's one word, ratio. Okay, that's a bit vague. Um, Circles. Reminder, area of a circle has a formula which you get given, which is pi r squared, r being the radius. If I said to you that this is the circle with a radius of 3, then we would do pi times 3 squared, and you would get, on a non-calculator paper, you would just leave it as 9 pi. If you had a calculator paper, then you would do 9 multiplied by pi, and you would get about 28.3 as the area of a circle. While we're there, because somebody mentioned the word sector, I'm just going to do that. I'm not entirely sure what you mean by sectors with Pythagoras and trig until you produce a question on this. And the other thing I should say, what I will do is I'll communicate this separately to all of you, but you should have a WhatsApp telephone number which will be shared to you, and it'll be on all your booklets going forward. But during these sessions, um, if you send questions during these sessions on the WhatsApp number, then I can pull them up live, as it were. So we can do that. But let's just quickly talk about this. If I said to you that this is a sector of a circle where this angle is, let's say, 30 degrees, then if you wanted the area of this shape, well, firstly, a sector is a section of a circle. So if it was a full circle, it would sort of be like that. And the area of it would be pi times 3 squared. Because it's not a full circle, it is this much of the circle. Remember, if this angle was full or complete, it would be 360 degrees. The fraction of the circle we've got is 30 degrees out of 360. So you would then multiply your pi r squared by this fraction to get the area of this sector. So 30 over 360 times pi times 9, essentially, would give you the area of that little piece. Okay. What else have we got coming up here? I'll try and go through each one of these. Oh my God, work out the length of PQ when Q is 1 Oh, right, that's not sectors. Okay, fine, I'll do that. If you have, by the way, specific questions from the homeworks, that feels like one of our homework questions, then you can point it out, because what I have conveniently done here is prepared the homeworks that we have given to year 10, year 11, and year 9 in the recent weeks. So I can just pull it up very quickly. Yeah, so that's that. So that is if you wanted to work out the area of a section of a circle. That's more or less area. I mean, there's not much more to area, really. There's no other shapes I can immediately think of that you have to worry about. Just on volume, the volume of a shape is the space inside a three-dimensional shape. Now, what you have to do here is understand that there is a difference between three-dimensional shapes that are prisms and three-dimensional shapes that are not prisms. A prism is a shape, is a 3D shape that's the same 2D shape all the way through. So, for example, if I have this shape and I sort of extend it that way, then that is a prism. It is a cube or a cuboid. If I had a circle and I extended it straight, then it would be a cylinder. That is a prism. Whereas what isn't a prism would be something like a cone, because it's not the same shape all the way through. When it comes to shapes that are not prisms, they have their own individual formulae to work out their volume. For example, a cone is a third pi r squared h that you get given. A sphere is another one, which is 4/3 pi r cubed. So these shapes have their own sort of separate formulae when it comes to volume. I'm going to focus on the prisms for now because they're a little bit easier. If I wanted to work out the volume of a prism, you find the area of the shape at the front and times it by how long the shape is. So, for example, if this was a cube. Now, most people know that if I said that was 3, 3, and 3, the volume is 3 times 3 times 3. But let's make sure we understand why it's 3 times 3 times 3. It's because this area at the front is 3 times 3. Okay, that bit there is 3 times 3. And then what you do with that area is multiply it by how long the shape is. So that's why it's 3 times 3 times 3. But it's important to understand that when it comes to more complex shapes. If we had a cuboid, and I said that was 4, 2, and 5, then the area, that's a bit bent, the area of the front of it is 4 times 2, because it's a rectangle. But then if I want the volume, I times that by how long the shape is. Again, I'm sure if you saw that question, you would do 4 times 2 times 5 without concern. Um, okay, I will make sure I go through all of these questions. Right. So that would be that. If it was a cylinder, again, I'm not drawing these very well because it doesn't really matter. But if it was a cylinder, then if I said to you, let's work out the volume of this shape, and I gave you those numbers, then what you would do first is work out the area of the circle at the front, which is pi times 3 squared, if you know your area formulae. You would then, because that's just the area of the front, and it's a prism, which is just a circle stretched out, essentially, then you multiply that by this 5. You type all that into the calculator, you get the volume of that prism. And it's important to understand that that is what we're doing here. We're working out the area of the front and then timesing over how long it is, because you could get a more complicated sort of shape. You could even get a 3D trapezium, I suppose, if you really wanted to imagine that. In which case, I'm not going to do this one, but if you wanted to work out the volume of this, you would take the area of the shape at the front and times it by how long the shape is. Um, so that would be essentially how you work out the volume of prisms. As I said, when it comes to shapes that are not prisms, then there is a separate way to work out their volume, and there is a formula for each one of those that you will get given. Right, let me specifically answer some of the questions that have been asked here, which one of them is question 12 in the year 10 one. Let me have a look at it. Yep, that one. Yep, so that's when you've asked it. Okay. Right, this question, it says work out the length of PQ. So because, and PQ is there. Okay. Now, because this has been drawn on the graph, it makes it a little bit easier. The problem that people have here is that because these are coordinates, they don't know what the length of these lines are. Okay. But you do, because since you have the coordinates, and that's 1, 6, then that means that the x coordinate here is 1, and the y coordinate here is 6. If we take the other point, then the x coordinate here is 9, and the y coordinate is 2, which tells me that to get from here to here, there is a gap of 4, which means this side is 4 long. To get from here to here, it is 8 long, which means this side here is 8. So essentially what we have done is created, if we redraw this right angle triangle somewhere, we have a side there that's 4 and a side there that's 8. Just make sure I'm looking at that right. 4, 8, yep. And now, to work out this side, you should know how to do it because it is a standard Pythagoras question where this side squared plus this side squared equals this side squared. 4 squared add 8 squared equals x squared. That's 16 plus 64 is x squared. 16 plus 64 looks like it's 80, and therefore x is the square root of 80. Get the calculator. Square root of 80 should be close to 9. It is 8.94, and the question wanted it to 3 significant figures. Therefore, it is 8.94. I trust that answers that particular question. Question 9 and 10 that someone has asked for. Right, question 9 and 10. Right, question 9 is here. I'm going to try and do everything. Question 6 in the year 9 booklet. Yes, I'll do that as well. That booklet, by the way, in particular, was quite difficult, and I think I will go through quite a bit of this because it was pretty rough, and it will be helpful for everyone. Because I guarantee you don't all know how to do these. But let me try and do these. Yeah, I'll do the year 11 and the functions and the perpendicular stuff secondary, as it were. Um, oh my God, you just need to ask it once. Question 12 for year 10. Right, okay, done that. Question 12 for year 10, question 12 for year 10. Question 12 for year 10, question 12 for year 10. Right, done that. 9 and 10 on this one. So question 9. Let's just make this bigger. I can show you it. Um, Question 9. Work out the ratio px to xq. Now, when you see a question like this, you're basically working out this and you're working out this. So px is this side here and xq is this side here. So let's not worry about the ratio for now. Let's just focus on getting those numbers that we need. So in order to work out this side here, I'm going to call it, just because we have an x there, I'm going to call it a, just for the sake of it. This side squared plus this side squared must equal this side squared because this is a right angle triangle. So a squared plus 16 squared equals 20 squared, which means that a squared is 20 squared, take away 16 squared, which I will get to the calculator for. It's 144. Therefore, a is the square root of 144, which is 12. Then this side here, let's call it b, just for the sake of it for now. We also need to work out that side. So that side squared plus this side squared equals this side squared. B squared plus 16 squared is 34 squared. B squared plus 16 squared equals 34 squared because it is another right-angled triangle. B squared is 34 squared, take away 16 squared. Let's work that out. Which is 900. Which means that b squared is the square root of 900, which will be 30. 30, right. So what you have done, sorry, b is 30, which means what you have done is you have worked out this side and you have worked out this side. The answer just wants the ratio of that side to that side. The answers were 12 and 30. So it is a ratio of initially 12 to 30. And then ratios are just like fractions. They can be simplified. So what you should notice is both of them go into 6, for example, or 6 goes into both of them. So it should be 2 to 5. But if in doubt, if you type in 12/30ths on your calculator, it will simplify it for you to 2 to 5. So 2 to 5 is the answer to that question on that booklet. So question 9. Question 10 was this one, where we have a man who is 1.8 meters tall, right? Work out the height of the building, which is H on the diagram. Okay, what we're going to do first is just look at this triangle and use trigonometry, because it's a right angle triangle, to work out what this side here is. I'm going to call it X. So on that right angle triangle, this, remember when you do trigonometry, you need to label your sides correctly. They should be H, O, and A as your labels. So your H is across from the right angle, so that's your H. Your O is opposite the angle that you're using in the question, and the A is the one that's left. You then refer to SOHCAHTOA, and you decide which of those three you're going to use based on the information in the question. So we have got the A, which is 40 meters, and we would like to work out the O, which is our X. So we're going to use O and A, which comes from TOA. So tan of this angle, which is 35, remember after sine, cos, or tan, you always put an angle, equals the opposite, which is our x, let's call it, over the adjacent, which is 40. From rearranging this equation, you will multiply this by this. So 40 times tan 35 will give you what x is, which is 28. So we've got x as being 28. Now remember, the question is to work out the height of the building. So we have just worked out the height effectively from here to about here, which we've just said is 28 meters. But because we're a little bit off the ground, we need to figure out what that extra bit is. And we know what the extra bit is because it's the height of the man. So that extra bit is 1.8 meters. So by my reckoning, the answer to this question is 29.8 because you'd add on the 1.8 to the 28 to work out the height of the building. Okay. I will get to the perpendicular. Right, let me see where we are with all this. I will get to the composite and inverse functions ASAP. Solving equations, yeah, I'll do some of that. I just want to get through the homework bits if I can. Nets, I probably won't do, if I'm being honest with you, because it's just a bit tricky to find questions on it. And then question 6 in the year 9 booklet. Yeah, I want to find that. So this question, which appears to be what we're being asked here, um, says that Lucy is investigating areas and perimeters of shapes. She makes a square with a perimeter of 24 centimeters. Calculate the area of her square. Um, so the square has a perimeter of 24. Now, a square has 4 equal sides, which tells me that in order to work out one of these sides, we should just be able to take the perimeter and divide it by 4, because that gives you 6, which means this must be 6, 6, 6, 6 all the way around. The question is to work out the area of her square, which you can get by multiplying 6 by 6. So the area is 36 centimeters squared. And then Lucy makes a rectangle with a perimeter of 24. The length is twice the width. Now, there's a couple of different ways to do this. I guess you have to work out the area of this one as well. Now, this side plus this side plus this side plus this side have to add up to 24, which also means that this side and this side must add up to 12, right? Because then the other two add up to 12 as well. And also, we know that one number is twice as big as the other number. So what you have to do, you could do a bit of trial and error here to figure it out. You have to figure out what two numbers add to give 12, where one is twice as big as the other. And you probably quite quickly can figure out that that is 8 and 4, because 8 is twice as big as 4, and they add up to 12. If that is 8 and that is 4, then all of them now give a perimeter of 24. And now the question is the area of the rectangle. 8 times 4 is 32, which should be the area of the rectangle. And then part C, which looks far more complicated. Lucy makes a different rectangle with an area of 34. The sides of Lucy's rectangle are x and 12 minus x. She wants to find a value where that equals 34. So normally, if I was finding the area of this shape, I would multiply this by this, and I've told you that it equals 34. So that's correct, I suppose, what's written down here so far. Keep an eye on any comments here. Yeah, I will get to that. Oh, yeah, part C, right? Yeah, I'm on part C now, right? Fine. She wants to find a value of between which one decimal place does X lie? Right, this is supposed to be a sort of trial and error question. So what they've done is you have X being multiplied by 12 take away X. That's what you're doing. You're multiplying those two things together. So what they've done is we've tried 3, and when you have X is 3, then 12 take away X, if X is 3, would be 9. Now, if they were the two numbers, they times to give 27. But we want it to make 34. So what we want to do is make the numbers a bit bigger. So if we tried 4, then over here we would have 12 take away 4 now, which is 8. And 4 times 8 is 32, which means, once again, we are a little bit too low, aren't we? So, because we're trying to get to 34. So if I tried 5, it's going to be too big, but let's do it. 12 take away 5 now is 7. And 7 times 5 is 35. Now we're too big because we're trying to get to 34, aren't we? We've made that a bit too big. So now what we're going to do is try numbers between 4 and 5 because it mentions one decimal place here. So we're going to do numbers between. This is where you'd need a calculator at this point. You'd expect a calculator here. So because we're quite close to 35, I'm going to just try a little bit smaller than what I tried before. So 4.9. If x is 4.9, then 12 take away x, get the calculator out now, is 7.1. And if I times those two together, then I get 34.79. Now, once again, I'm a bit too big, aren't I? Because I'm trying to get to 34. So I'll make it a little bit smaller, 4.8. If x is 4.8, then 12 take away that is 7.2. If I times those two together, I get 34.56. God. I'm going to have to keep going, aren't I? If we do 4.7, then this is 7.3. So it's much smaller, isn't it? 4.7 times 7.3 is 34.31. It's getting ridiculous. All right, let's drop down a little bit lower. If we keep doing this with 4.6, then it'll be 4.6 times 7.4, which is 34.04. And now if you did it with 4.5, and that would be 7.5, then you finally will drop below 34 to 33.75, which tells us that our answer is somewhere in the middle here because we're trying to get to 34. So that means that the answer of x is somewhere between these two numbers. And the question wants you to say, between which one decimal place numbers does x lie? It must be between 4.5 and 4.6. Quite a complicated question, but it requires a bit of trial and error to get there. Right. Um, okay, that was all of that. Hopefully that was all clear enough. What time are we on? 7:30. Right. What I will do first then is I will do the question from the Year 11 booklet. Um, because that's all everybody's asked so far. And then I will try to do some of the solving equations. And you mentioned probability and Venn diagram hard question. I'll try and find that. And I will try and find some inverse and composite function. This is going to be slightly more relevant to um, the higher level year 11 stuff, just so you know. So with these sessions, I'll say I've called everybody in year 9 to 11. With maths, it's a bit awkward, but with the sciences, it's all going to, when we get to the science stuff, it's all going to be easy enough for everybody. So just bear that in mind. So remember, with these sessions, come and go as and when you please. So I'm not going to watch what's going on. So the question has been asked, which is, I'm trying to find it now. 8C on year 11 perpendicular lines. Okay. So these weren't that easy, these questions. Right, let me explain. We have a circle. Okay, it's spelled wrong. Um, and we want to work out the equation of the tangent to the circle. So what I'm going to do is I'm going to draw a little graph to help with this. The circle's approximately there. When you have an equation of a circle that looks like this, which you will only get at GCSE, then it means the center of the circle is in the middle. They said P is the point 1, 2. Let's just pretend that point 1, 2 is over here somewhere. Okay, 1, 2. The question is to work out the equation of the tangent to this circle. So the tangent looks a bit like that. Okay, again, roughly. So we want to find the equation of that line. The equation of the line is y equals mx plus c. That is how we want to initially think of the equation of a straight line, because then it clears your mind as to working out what the m and the c is only. You just have to fill in those two numbers. That's all we need to do. So how do we do that? What we will do is we will first draw a line that goes from the middle to the edge of the circle to the point where the tangent just touches it. The reason for that is, and it's this to do with the circle theorem rule, the radius and a tangent meet at a right angle from a circle theorem that you learned at some point. And what that means is that the blue line here and the red line are perpendicular, hence the topic. And when two lines are perpendicular, there is a relationship between their gradients. What I'm going to do first is find the gradient of the radius, which is the blue line. So what I know about this radius is that it goes through 0, 0, and it goes through the point 1, 2. Just making sure I did that right. To find the gradient between 2 points, basically there is a formula for it, which is the change in the y coordinates divided by the change in the x coordinates. But all I do is I just look at these 2 points and I say, what has happened to the y coordinates? We've added 2. What's happened to the x coordinates? We've added 1. The gradient is this number divided by this number. So 2 over 1, which is just 2. So the gradient of this blue line is 2. Now, what I said earlier is that there is a relationship between the gradient of perpendicular lines. So if the blue line is perpendicular to the red line, there is now an easy way to work out the gradient of the red line because it is minus a half. What you do to get the gradient of a perpendicular line is you flip over one of the gradients and change the sign. So if it was positive 2, flip it over to a half, and then because it's positive, change it to a negative. So that is the gradient of my red line, which means that I can go to here and fill in the m, because remember the m is the gradient, to minus a half. Now all that's left to find is the c, because we've basically done half the question there. To find the c, what we do is we use this coordinate, the one that the line goes through. The line goes through the coordinates 1, 2. We know that. And we can use that point to figure out what's left in this equation. What we do is we take the x coordinate and put it in there, and we take the y coordinate and put it in there, and then we rearrange this to find the c. And this kind of helps with the rearranging equations thing. Change the y to 2. If x is 1, minus a half times 1 is minus a half. It stays the same, plus c. To find out what the c is, I move this to this side, and if it's a negative, you add it to the other side. 2 plus a half is what c is, which is 2.5. You can write it as a decimal if you like. And therefore, the answer to this question, because we now know what c is y equals minus a half x plus 2.5. That'll be fine. You can write it as 5 over 2 if you prefer. And that is the answer to that question. That is how you do a question on that perpendicular lines thing. Question 4 in the year 9 thing. Yeah, I'll do that as well. It's been asked. Somewhere over here. As I said, this was a really tough one. Right, this King Arthur thing. Right. There is a large table known as the round table of King Arthur. The diameter of the table. Diameter is the distance all the way across the middle of a circle. Diameter. So the diameter is 5.5. Remember, what we can do with that information before I go any further is two things. We could find the area of this entire table, or we could also find what's called the circumference, which is the distance around the outside. There's two slightly different formulae for that. In this question, it says a book claims that 50 people sat around the table. Assume each person needs 45 centimeters around the circumference of the table. Is it possible for 50 people to sit around the table? What we need to do clearly is work out the circumference of this table. The circumference formula is 2 times pi times the radius, or just pi times the diameter, because 2 times the radius is the diameter. So to work out the circumference of this whole table, which means the distance around the outside of the table, we do pi times the diameter, which is 5.5. Pi times 5.5 is 17.3, let's call it. 17.278. Okay. I'm going to call it 17.3. We'll see what happens. Then we know that one person needs 45 centimeters to fit around the table. Now, what we're going to do here is just notice that this is in meters and this is in centimeters. When you do any sort of question, whether it's maths or physics and stuff, you need to make sure your units are consistent. So if we've used meters so far, we need to continue to use meters. So I'm going to change that 45 centimeters to meters by dividing it by 100. It is 0.45 meters. There's a couple of ways to do the next bit now. You could divide this by this and see if it makes 50 or not. Or what you could do is just say, well, if one person has needs this much space, then 50 people would have needed that much space, right? 50 times 0.45. Now, 50 people would have needed 22.5 meters around the outside of the table, but we just worked out a minute ago that the outside of the table is only 17.3 meters. So the book that claims that 50 people sat around the table is wrong. It is not possible for 50 people to sit around the table because the total distance around the table is 17.3 and 50 people would have needed 22.5 meters to sit around that table. Don't you, yeah, I did, don't you? Meters to centimeters, yeah. I mean, it does, either way around is fine. You could convert the meters to centimeters, or you could convert the centimeters to meters. Either way, you'll get to the answer. Because if it was all centimeters, this would have been 1,730 centimeters, and this would have been 2,250 centimeters. Either way, this number is bigger than that number, which means that you can't get 50 people around that table. And that should cover all of that. Right. I think I've done all of those. Someone mentioned the rearranging equations with brackets and expanding brackets. So I'm just going to do one question on that, and then I'll move on to the slightly harder stuff. So if you are in year 9 slash, well, year 9 really, then it might be a bit beyond you, but you can follow along if you wish to. Right. It's just one question on, I'll make it up completely with brackets on both sides and expanding and stuff. So, for example, 3 times 2x plus 9 equals 7, 3, 4, I was making this up, minus 1. Okay. Yeah, 9, question 6. Okay, I'll get to that in a moment. Oh, so yeah, sorry. I'll get to that again. I've just realized that I've not done all of that. I'll just do this and I'll come back to that question. That's part B or whatever. 3 times 2x is 6x. 3 times 9 is 27. That is how you expand a bracket. The bit outside has to be times by everything in it. Same again here. 7 times 4 is 28x. And 7 times minus 1 is minus 7. So now we get to this point. What you need to do is get the x's on the same side and the numbers on the other side. You can choose which side you choose, which side you want. And what I generally recommend to avoid negative numbers is that whichever side already has more x's on, keep them there. So what I would do is move this to this side. If I do this very longhand, then I would be left with 27 on the left-hand side. On the right-hand side, I've got 28x minus 7, take away 6x. That 6x becomes a takeaway on this side. Then what you should do is simplify where you can. 28x take away 6x is 22x. At that point, you've got your x's together. Now I need to move the numbers. So I'm going to move this minus 7 to this side, but then it will be added to that side because a minus gets added to the other side. 27 add 7 is 34. And then finally, you would divide by 22 because I've made this up. It's an awkward fraction, but that is the answer to the question. You could simplify it. You could write it as a decimal, do whatever you like. And that would be that. Right. Part B, apparently I missed somewhere. Okay. Assume people sitting around the table could reach only 1.5 meters. So this is back to that table. Assume people sitting around the table could reach only 1.5 meters. Okay, so that's a person here. Can only reach 1.5 meters. Um, Calculate the area of the table that could be reached. Essentially, they're saying work out the shaded area here. That may as well be the question. The shaded area is the bit that people can reach, right? If you're sat on a table, there's a limit to how far you can reach across it. Um, so they can only reach that far. So all of them could reach sort of here, couldn't they? So the question is basically work out the shaded area. To work out the shaded area, we are going to work out the area of this entire circle using this radius, okay, because that is the radius of that big circle. It is 2.75. So the big circle, the area would be pi times the radius, which is 2.75 squared. Okay, that would be the big circle. Then it gets a tiny bit complicated, but we'll come to that in a second. But let's do that bit first to get some marks. So the big circle is pi times 2.75 squared, which is 23.75, 23.76, let's call it. Okay, that is the full area of the circle. Now, to work out what I want to do now is from that, take away the smaller circle. The problem with that is that you don't immediately know the distance from the middle to the edge of that circle, but you kind of do. Because from the middle to the edge of this circle is 2.75 meters, which means that just this much of it must be 2.75, take away that 1.5, which is 1.25. So that means the distance from here to here must be 1.25 meters. And with that radius, we can work out the area of the white circle here. So the small circle, the area of it is pi times that radius squared, which is 4.91 roughly. Okay, and then to work out the shaded bit, which is the bit that they can reach, it will be this number, take away this number. So 23.76, take away 4.91, and then I'll let you do that bit yourself. That would be the answer to that question. Question number 6 has been mentioned as well. Year 9, question number 6. I'll try and get through this as fast as I can. I did know question number 6, sorry. And then question 4, part B. Did I do that? Did all that, right? Okay, so I've done all of that. I'm not doing any of the year 9 stuff now. Let's now move on to, okay, so I did the solving equations. 10 and 11 on the year 11 booklet. Yes, I can do that, hopefully. Did I do any of those a second ago? The numbers weren't on here, were they? Okay, fine. So if that's 8, that's 9. I guess that's 10. Right, fine. And that's probably 11. Right, so the last two questions. I shall do those because they are reasonably complicated. And then what I will do is I'll try to get to doing some functions, and I might do a probability question as well from the more advanced one. I don't, so it might, we will go over the hour. It's all right. I've got nothing to do. Right. Okay. Let me do this, which I assume is question 10, which is what you've asked for. So, reasonably complicated question, this. But they've asked you to work out the coordinates of this point P over here. Now, what do we know? We know that the point A has coordinates 0, 5. So that is 5. Point B has coordinates 3, -4. So that's 3, -4. And then they want you to work out the coordinates of P. Now, one thing I know about P already, without fail, is that this is a horizontal line because it goes through 0, 5. And therefore, this coordinate is already, sorry, not that coordinate, the y coordinate of P is already 5, isn't it? It has to be. The y coordinate's 5. Really, or we because it's in line with this 5, so it has to be. So we just need to work out the x coordinate. Um, that's all we need to do. And the x coordinate is where these two lines meet each other. Now, I technically already have the equation of this line. A horizontal line always has equation y equals something. So y equals 2, 3, 4, 5, or whatever. And it's wherever it crosses the y-axis. So that is already y equals 5. We're really now just trying to find the equation of the other line. Because once we found that, the rest of it's going to be easy. So I need to find the equation of... I'm just going to color it. This line here. I'm going to find the equation of this line. And it's the same as the previous question I did, actually. So if that's the center of the circle, which it is, 0, 0, then this line here, this black line, is a radius of that circle. And because I've drawn it to meet the tangent at that point, those two lines are perpendicular. Therefore, if I can find the gradient of this line, then I can do that relationship thing, the flip over and all that, to work out the gradient of the green line. So the black line here goes through 0, 0, and through 3, -4. To find the gradient, the quickest way to find the gradient is to do the change in the y coordinates, which is -4, over the change in the x coordinates, which is 3. That gives you a gradient of -4 over 3. That is the gradient of the black line. Therefore, the gradient of the green line is flip over and change the sign, 3/4, because perpendicular lines have that connection in that gradient, which means that the gradient of that the equation of the green line is 3/4 x plus something. Okay, because that's the gradient. I just need to find out what the something is. To find out what the something is, the c, you substitute in the point that the line goes through, which is the 3 minus 4 again. So when y is -4, x is 3. So I'm going to put 3 into there. 3/4 times 3 is 9/4. Again, you can use a calculator or not, whatever. Plus c. And c, therefore, is 4, -4. Take away 9/4, which is going to be -25/4, just because it is, but use your calculator. It is -25 over 4. That is what the c is, which means that the final equation is y equals 3/4 x minus 25 over 4. That would be the equation of that line. Now, we still haven't finished because we haven't worked out the point coordinates of P. We have two lines, y equals 5 and y equals this. What we need to do is find out where they meet. So what you do to find where two lines meet each other or two equations meet each other is you equate them. So if you've got y equals and y equals, you put them equal to each other. So we would say 3/4 x minus 25 over 4, that's one of them, equals the other one, which is 5. So that's where they meet, where they're equal. And then from here, it's really up to you how you want to do this. What I would do is I would multiply everything by 4, because that would give me 3x minus 25 equals 20 if you times everything by 4. Then I would add the 25 to get 45, and then I would divide by 3. 45 divided by 3 is 15. X is 15, and we already know the y coordinate, as I said. It was 5, because it was already in line with that. So the answer to the question is 15, 5 as the coordinates of the point P. And lastly, we'll do question 11, which I think is question 11. We have a circle once again. Okay, roughly. There is a point 39. Oh, it's going to be a bit awkward, this. Yeah, point P 39. Let's pretend it's there. It tells you the line, sorry, the line L, which is a tangent here, crosses the x-axis at the point Q. So that's where that is. Well, that crosses the x-axis. And it wants you to work out the area of triangle OPQ, O being the center of the circle. It always is. Okay, so we are going to have to work out the area of this triangle. It's very important sometimes to draw a sketch to visualize what on earth is happening. In order to work out the area of that triangle, how do you work out the area of a triangle? We did it at the beginning. It's half base times height. we actually already know the height of this triangle because the height is the vertical height. That's the one we want. The vertical height of this triangle is 9 because point P has y coordinate 9. See what I mean? That's 9. So we've already got the height of it. We really just need the base of the triangle. In order to find the base of the triangle, which is this length here, I really just need the coordinates of point Q. Because if I've got the coordinates of point Q, let's say it's 5, then the base is 5 because it goes from 0 to 5. Don't know what it is though. Now, in order to find the coordinates of point Q, I have to do everything I just did in the previous question and the one before, which is find the equation of that red line. And I'll explain why once I've found the equation of that red line. How do you find the equation of that red line? Same thing again. This line here, O to P, is the radius of that circle. It is meeting a tangent. It meets it at a 90-degree, at a 90-degree angle, which means that they're perpendicular. The blue line, I know there's many blue lines, the radius goes through 0, 0, and 3, 9. The change in the y coordinates is 9. The change in the x coordinates is 3. The gradient, therefore, is 9 over 3, which is 3. That's the gradient of the radius. We want the gradient of the tangent. Therefore, it must be minus a third. Flip over and change the sign. That is the gradient of our tangent. So my equation of the tangent is y equals minus a third x plus something. Don't know what something is yet. I'm going to find the something. The way I will find the something is using this point again, 3, 9, because I know it goes through that point. It's the only point I know that it goes through. When y is 9, x is 3. Minus a third times 3 is minus 1, which means that the c is 9 add 1, which is 10. So my equation of that line is y equals minus a third x plus 10. Okay. Why was it useful to find the equation of the line? Because from the equation of a line, it is very easy to find out where that line crosses an axis. We know where it crosses the y-axis. It crosses it at 10. It tells you there. But that's not the one we want. We want to know where it crosses this axis. The one thing we know about where a line crosses the x-axis is that the y coordinate is 0. It's something 0, definitely. So what you do now is say, well, I know the y coordinate is 0. I just need to know the x coordinate. Now, because I've got the equation, I can well, let's say the y coordinate is 0. I can work out what the x coordinate is by rearranging this equation. I would add a third x over and then times by 3, which means x is 30. Yeah, 30. So I know now that this point here is 30, which basically means that I can find the area of the triangle relatively easily. If we redraw the triangle that we have got a base of 30 and a vertical height of, what was it, 9, wasn't it? Yeah. And therefore, to find the area of that triangle, just to bring it all back to the beginning, is a half times 30 times 9, which is 15 times 9, which is what, 225, I think. Just check that. 135. That is the area of the triangle, and therefore we had to do all of that rubbish to get to there. Yes, so I will I might the question 1 in year 10 that you've just asked, I will have a look at it, but I will probably not immediately. We'll see how easy it is. Oh God. Okay. I'll do this, but I'll do it really quickly. It says work out the perimeter of this pentagon. To work out the perimeter, it means add up this side to this side to this side to this side to this side. We've already got this side, this side, and this side. That's 312, which is 36. Therefore, we just need to figure out what these sides are. And actually, we don't even need to figure out what those sides are because they're both the same. So once we work out one of them, we've got the other one. It's the same. What you have to do in this question is draw a line straight across here. And what that does is makes you realize that there is a 90-degree angle here because it's a square, and the rest of that 125 must be that angle. So 125 take away 90 is 35 degrees. So this and this is 35 degrees. What you then do, I don't know what you then do, is, yeah, draw a, this is the best way to do it. Draw a line there, and we've got a right angle triangle over here. And this side of the right angle triangle must be half of 12. So it's 6. So from that, if we just redraw this triangle, it must be 6 there, 35 degrees here. And then if we just call that x, then we can use trigonometry to work out the x over here. This is the hypotenuse. This is the opposite. This is the adjacent. And therefore, we can use SOHCAHTOA to work this out. That is cos 35 equals the adjacent, which is 6, over the hypotenuse, which is x. X is 6 divided by cos 35. You should have covered all of this, which is 7.3. Now, if that's 7.3, then that is also 7.3 when you add those two on to that 36 and you get your answer. Right, that is all of that done. I'm not going to do any of those homework questions anymore. I will do a little bit of functions and I will pick out a reasonably difficult probability equations question. How shall I do this? Do that. So right at the bottom here, you will find reasonably large number of questions on inverse and composite functions somewhere. There we go. Right, I'm gonna okay, pick out a question from here which hopefully covers all of these questions because we've got an inverse function. And, that's not a good one. That's not a good one. Um, yeah, we'll do two questions. So this one, and I'll do the one below it as well. Right. If you can understand the next two questions that I do, you will be more or less fine with inverse and composite functions. Just they aren't easy, but you know. Okay, just bring that one as well. I believe, oh no, in year 11 we have a lesson on this coming up soon. Okay, right. Firstly, it says find that, which is a composite function. The way you know it's a composite function is two letters next to each other. With composite functions, what we try to do is, well, what I'll do is I'll make it a little bit simpler first. If I said to you what is f2, what that means is you take the number 2 and put it into that function. So you'd get 3 times 2 is 6 plus 1 is 7. Easy enough. If I said f is, 3, you put 3 times 3 is 9 plus 1 is 10. But we haven't said that. We've said f, this. So essentially, it's asking us to take this whole thing and put it in there. And that means that you take all of this, which is the g function, and put it inside there. Now, when I say put it inside there, it means you replace the x with what you've got there. You don't multiply. What people do wrong here is they multiply this x by this x squared and get like 3x cubed. You are replacing the x with all of this. It's like inputting it in. So this x will be replaced by x squared. So the answer to this question is actually just that, which is a composite function. You have joined two functions together essentially by putting one into the other. The next question asks for it the other way around. It says take the f function and put it into the g function. So now what we're going to do is everything in reverse. We're going to take all of this and replace the x in this with all of that. Replace the x only. Everything else should stay as it is, just like the 1 stayed where it was. So if I replace this x with that, then it will give me 3x plus 1, all of that squared. That is an expression for gfx. It's just about subbing one equation into the other. And then it says, I need to move this down a bit. solve that equals that. So we've already worked out what this is. We did it in this bit over here, which is 3x squared plus 1. We've already worked out what this is because we did it in the second part. It was 3x plus 1 all squared. And then what we're going to do is solve this. The way you solve this is first you need to expand these brackets out. This is going to be awkward. I might not finish this question, but essentially that's the functions bit of it. Then it's now quadratic equations. If you expand this bracket out, you're going to get 9x squared plus 6x plus 1. Write it out twice, expand it. Just done it quickly. And then actually, it's not that bad. The ones will cancel out. So we've got 3x squared equals 9x squared plus 6x. If I bring this over, I've got 0 equals 6x squared plus 6x because I take away 3x squared from 9x squared. I could actually even divide by 6 now if you want to make life easier for yourself to get x squared plus x. And then what you're supposed to do, and this is now not functions anymore, it is a quadratic equation. When you have this kind of quadratic equation, when you don't have a number at the end, you take the x out and leave yourself with that. And then essentially you treat these as two separate brackets. One of them says x equals 0. The other one says x plus 1 equals 0. So your answers are that x equals 0 and x equals minus 1. They would be the answers to that question. Let me move to this one. Given that that equals that and that equals that, find an expression for this. Right, this little minus 1 is telling you this is an inverse function that we want. When you need to find an inverse function, there is a method that always works, and this is what you do. You take the original function and write y equals before it. That y is just temporarily there to help you rearrange this equation. What you then do with this equation is make x the subject. That means get the x by itself. Easy to do here. You just move the minus 3 over. So you get y minus 3 equals x. Now, this is essentially your answer, except for the fact that we didn't have any y's. The y was just temporarily there to help you rearrange it. You change that y back into an x for the final answer. So the final answer is just x minus 3. The inverse just means do the opposite to what's already happening. What's happening to the x here? We're adding 3. The inverse is take away 3. So that's why that is the answer. But the y just is there to help you rearrange it. Then same thing again, but this time for the f function. That's the f function. So I'm going to write y equals the f function, and I'm going to rearrange it to make x the subject. I'm going to add the 17 over, and then I'm going to square root. So it's the square root of y plus 17. But again, the y is only there temporarily to help you rearrange it. The final answer is the square root of x plus 17. And that would be that. And then just to finish this off, that's the inverse and composite thing done really. But they finally want you to solve this equals this. And just like the previous question, they are just the answers, the two previous answers that you just got. So the inverse of f was the square root of x add 17. The inverse of g was x minus 3. I couldn't find it. Okay, and now to do this question, again, I probably won't finish it off, but you square both sides to get rid of the square root. Don't forget that when you square something like this, it is not just squaring the x and just squaring the 3. It is all of it squared like that. If you expand the brackets out, you will get x squared minus 6x plus 9. Then what you need to do is, because it's a quadratic equation, get 0 on one side. Take away the x will give you minus 7x. Take away the 17. 9 take away 17 is minus 8. We probably can finish this. Two numbers at times to give minus 8 and add to give minus 7. It will be negative 8 and plus 1. That factorizes to x minus 8, x plus 1. And therefore, the final answer is x equals 8, x equals minus 1. That's the final answer to that. But the last bit of that isn't really functions, it's solving an equation. The functions bit is just understanding how to get an inverse function or how to sub one function into another, which is hopefully relatively straightforward once I've explained it. 3D trig, I'm not going to do. because it's really just trig and finding the triangles in a shape, which is awkward, but takes a bit of practice. And I am not going to do circle theorems at this point, just because. Um, but we can do it another time when we have fewer questions. There's quite a lot. Um, One question that was asked was, in fact, no, I can do the circle theorems. I think I've got time to do it, but let me do the in order. I'm not going to do ratio. I'll do that another time because it's too vague a question. Can you please talk about the question about probability and Venn diagram, especially hard questions? Right, I can do one or two. And once again, I will resort to this. Now, usually we can find them in here, but the Venn diagrams we might find in here. So I'll look at both of them. Um, so Venn diagram, I'll see what Venn diagram we've got first. Okay, I'm just going to go to this directly and do this one question because it is a Venn diagram question. The most important thing I can say about questions involving Venn diagrams is to start in the middle and work your way outwards. That would be what I would say. Um, so we have got 50 people who were asked if they like tea, coffee, and hot chocolate. Every person liked at least one of the drinks. In these questions, every single bit of information is really important. However, it's about the order in which you deal with it. So this is going to be horrible, this. Right. I'm going to draw three circles and I'm going to draw them badly. Okay, I'll roughly do. This is going to be my tea circle. This will be my coffee circle. This will be my hot chocolate circle. Um, it tells you that every person liked at least one of the drinks, which means there is nobody outside those three circles. So I'm going to put that in just for the sake of it. Then as I said, what you want to do is start in the middle. So and the middle means people that liked all three of the drinks. And we know that 17 people liked all three of the drinks. So I'm going to put 17 in the middle. Then it said that 31 people like hot chocolate. 34 people like tea and 21 people like tea and coffee. Now, this is where it gets a little bit tricky because you don't know which information to deal with first. We can't do anything with this 31 because that 31 is all of the people who like hot chocolate. Now, that doesn't tell me where the number goes because all of that circle is 31 people like hot chocolate, but does it go here or does it go here or does some of it go here, some of it go there? We don't know. So that doesn't really help me much. What does help me is 21 people like tea and coffee. Now, tea and coffee is this section here. Okay, that section there that I've just done in green, that's tea and coffee. It's the overlap of tea and coffee, of the T and C circles. Um, and we know that 21 people like tea and coffee, but we've already counted 17 of them. And this is how these questions work. You've already counted some of them, so you have to sort of discard those as you go. 21 people like tea and coffee, of which 17 also like hot chocolate. Okay, so that's the 17 that we've already got, which means that in this space, there must be four because that makes 21 altogether. 21 people liking tea and coffee, of which 17 like all three. Okay, then seven people like tea and hot chocolate, but not coffee. Now, tea and hot chocolate, but not coffee, is only this little section here. If you think about it, that's the overlap of tea and hot chocolate, but it already doesn't include the people who like coffee. So that little bit there is tea and hot chocolate, but not coffee, which means that that seven can just go straight into there because it is just one space. That's tea and hot. I got that right. Tea and hot chocolate, yes, but not coffee. And then it says two people like coffee and hot chocolate, but not tea. Now, coffee and hot chocolate is there, and they're the people who also, and it doesn't include the tea people, because otherwise the 17 of them also like tea. So two people like coffee and hot chocolate, but not tea. So that is everybody in that highlighted section. So two goes into there. So as you can see, we are sort of working from the middle outwards, and that's how you have to do these questions. Then we can go back to the rest of the information. 31 people like hot chocolate. That means in the entire hot chocolate circle, we should have 31 people. And we've got everything except for this space. So we can work out what goes in that space because it must be 31, take away what we've already included. So 7 add 2 is 9, 9 add 17 is 26, isn't it? Yeah. And then 31 people like hot chocolate. So 26 we've already counted, leaving us 5 who only like hot chocolate and nothing else. Because the other numbers include the hot chocolate people, but they like other drinks as well. What else we got? 34 people like tea. 34 people like tea. Again, the tea circle is all of this one here. And we already know that there are 28 already. If you add those three numbers up, 28 we've already got, which means that that leaves you with 6 that must like tea only. So now that our Venn diagram shows that 34 people like tea because the numbers inside the tea circle do add up to 34. Lastly, we're left with the people who like coffee only. And there is no information about what can go here, but there is. When you have one space left on a Venn diagram, as we do here, was literally one gap left, then what you can do is look at the number of people in total in the question and basically subtract everything you've already got in the diagram from that number, and that must leave you with the people in the one space. So if I try and do this in my head, that's 34, wasn't it? 34 add 7 is 41. I've got 41 people counted so far in this Venn diagram, but there were 50 people altogether, which means that 9 must be left over in that circle over here. And that is a completed Venn diagram. And then we can just figure out this. It says two of the people, this is a little bit hard, this last bit. It says two people are chosen at random. So just, if it's a Venn diagram question, that's done. Now it's just a probability question. Two of the 50 people are chosen at random. Work out the probability that they both like coffee. Well, we know that there are a total of how many people in the coffee circle? 9 add 2 is 11, add 7 is 28, add 4 is 32. So 32 people like coffee. Remember, it just says like coffee, not only coffee. If it was only coffee, then we would just said those 9 people. But it is um 32 people like coffee. Right. If we're picking two people at random, then the probability of one person liking coffee is 32 out of 50. The next person that we've picked, what you have to realize here is that when you're picking two people, you're picking one and then another. So you're taking one out effectively of your selection. So what you would do now is times that by the probability of picking another person who likes coffee. Now, another person who likes coffee. I'm just making sure this is like 13. Yeah. There's one less person to choose from and one less person overall. So you have to reduce everything by one for the two people like coffee. You'd work that out on your calculator and you'd get the answer to that question. Okay, I think we're more or less done with that. Challenging questions on circle theorems again, a little bit vague. I will also, just so you know, in future, I will ask that we present our names on the things. So where it says anonymous attendee, I am in future. I appreciate on this one, but in future I will ask that I can see everybody's names. So at least I know who I'm dealing with. Circle theorems. Let's do a couple of questions from this circle theorems thing, and that'll be it. Where are they? Well, it depends on what you mean by challenging question, you see, because there's actually something that's very challenging involving circle theorems, which is the proof of the circle theorems, which we can do another time. But if you want challenging questions, then that is as challenging as it gets. Um, but I suspect that isn't what you're talking about, which is why I will pick out something from the bottom of this. We'll see what happens. Um, right, something like this would be possibly a challenging circle theorems question, partly because it has angles in it, although this really isn't, to be honest. Particularly challenging. Right. Um, what you are supposed to know on this question is that there is a circle theorem that says when you have a diameter of a circle, and how do we know it's a diameter? Because it goes through the center, which is labeled O. If the edges of that diameter go and make an angle somewhere, then the angle they make is a 90-degree angle. And now to work out x, I mean, this is pretty straightforward. Those three angles have to add up to 180, which means those two have to add up to 90, right? We've already got 90 of it. So 3x plus 2x must equal 90. 5x equals 90. X is 90 over 5, which I think is 16. And that is what x is. So that is a relatively straightforward circle theorems question, I accept. But until you send some to me, I can't be that precise about it. Um, I mean, even that, yeah, I don't think any of these are hard enough, to be honest. Um, right, I won't do any more unless I get sent some. But as I say, what I'll do is I'll communicate this better for next week, where if you have any specific questions, you can send them to us over our WhatsApp. And then we'll take it from there. Right, I'm not going to do any more for today. Hopefully that was useful, and we will do it again every Wednesday. Optional, of course, attendance each time. So I will finish there. And yeah, if you have any other questions, drop us an email.